Welcome to week 13, Properties of Logarithm. So we have some of the rule. We have product rule for the first line, rule number 1. Log by b of product m times n equal log by b of m plus log by b of n. Then we have quotient rule. Rule number 2, that log by b of the m divided by n, we have log by b of m minus log by b of n. So remember, always we have multiplications. It look like that, right? And then we turn it to make it plus. And we have divide, like that. You see the bar, right? So it will go to minus the bar right here to memorize it. And this one you rotate it around, right? So you got plus. That's how we remember it. And for the power is rule number 3, log by b of m to the power of k. We bring k in the front. Here, k in the front. That power rule. And rule number 4, we have log by b of 1 is equal 0 because b to the power of 0 equal 1. Any number raised to the power of 0 will be equal 1. Similar to this, b to the power of 1 is b. So for this one, log, we have log by a equals c is the same thing as b to the power of c equal a, right? So now rule number 6, you have log by b. If you change that, you will have b to the power of k. That's our a right here, right? So equal b to the power of k, so that's true. Then we have rule number 7, b to log of by b to the power of k is equal k. So this one means if we have log b and log, you can cancel that, so k equal k. It's inverse, right? And one important rule is chain of base. So if we have any log by b of a, it will be the same as log by, this is they call it by x, but we can call like some c, so in different from the variable x. So log by c, any c, any number, positive number. So is equal log by c of a over log by c of b. So it will be the same base, or we can make it 1 over log by a of b. How it's happened? So from here to here, it's like you make the reciprocal, right? So it's like you have log c of b over log by c of a. And if you flip it, right? You flip it, you have that log by c of a over log by c of b. Because 1 divided by the fraction is 1 multiplied by reciprocal, and reciprocal of log c log base c of b over log base c of a will be log base c of a over log base c of b. And this one, we see that we have the same base c, right? We can write down at log whatever at the bottoms will be the base, right? So a right here and then b on the top is above. So to remember this formula, just remember that log by any base number, we can choose c, right? And then a is a little bit above b, base always at bottom. And then a is right, when we draw it, it's above b, so it will be on the top. Okay, let's practice. So we have log base 2 of a times x, right? So we have log base 2 of a times x. So we see that we have the product rule here. We can rewrite at log base 2 of 8, and then we plus log base 2 of x. And to be simplified this one, we have log base 2 of a is 2 to the power of 3. So we will say 2 raised to what power equal 8, and the answer is 3. So plus log base 2 of x. That should be the answer, right? So right here, if you don't get it, it's 2 right here is a, that equals 3, because we have 2 to the power of 3. 2 to the power of 3 equal a. Yep. Okay. Now we have this one. Log base 3. Log base 3 of 81x. 81x over 27. So we have the product where it's 81 times x, right? And also we have a quotient, a part right here. So let's separate the log extended by using quotient rule first. So by using quotient rule, I will have log base 3 of 81x, right, at the top, minus log base 3 of 27. Here, this is the rule we use. So our m is 81 times x, and our n is 27. Yeah. So now the first log base 3 of 81 times x, we can rewrite at log base 3 of 81. Now multiplication, then we use the rule number 1, product rule. Here, product rule here. Okay. So we will have log base 3 of 81. Now multiplication plus log base 3 of x. Now remember, that is our first term right here. Continue to write down the last term. Okay, that equal 81 is 9 times 9. 81 is 9 times 9. Is 3 squared times 3 squared, that 3 to the power of 4. So 3 raised to the power of 4 is equal 81 plus log by 3 of x. We could not simplify that. And then we have 27. 27 is 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. That's 3 to the power of 3. So 3 raised to the power of 3 equals 27. Now we will have 4 minus 3 is 1. So 1 plus log by 3 of x. Now we try to apply the power rule here. Power, because we have some term right here and then we have the power. So log base 5 of x to the power of 3. Now that is 3. So our m is x. M is x. Right? And then k, what is k? K is 3. So the thing is we bring that one in the front. Right? So this one will be equal 3 log base 5 of x. Now log base 4 of 1. Log base 4 of 1 equal to, so 4 raised to what power equal to 1? 0, right? And this is rule number 4. To any log of any base, log of any base of 1 is equal 0. Because any number raised to power of 0 is equal 1. Not 0. We never have log of any number, log of any base of any number equal 0. Remember, we have the graph of the log is have the vertical asymptote at x equals 0 or y axis, right? So the vertical asymptote is right at here. So it's never touch that. It means it never be 0. So remember, any number raised to the power of 0 will be equal 1. So log of any number any base of 1 that equals 0. Alright, now this one is log of base 800. Log base 800 of 800 is equal to 1. Any number raised to power 1 is itself. So a to the power of 1 is a, x to the power of 1 is x, right? So 800 raised to the power of 1, that's 800. That makes sense, right? The base always is at the bottom, right? Is the lowest number. Then we raise to the right of the equal sign and equal to the inside of the log. So we use rule 5. Log of base b of b equal 1. Now we have log base 2 of 2 to the power of 300. Alright, so now we have log base 2 of 300. That equal 300 because we have 2 to the power of 300 is equal to 2 to the power of 300. and that is rule number 6. B equal 2, and then K equal 300. Now we have 3 log by 3 of 17. So 3 log 3. So this one we call base as well for the exponential, right? Exponential functions, that is called the base. For the log, the base at the bottom, right? And this one is invert functions. So exponential and logarithm functions are inverse functions. So that will be cancel out, right? And we left with 17. In this case, we use rule number 7, and B is 3, K is 17. Now we have number 8, and we try to use the chain of base rule. So we have log base 16 of 64 that equal to, we see that we can have it in common of 4, right? 16 can be 4 square, or 64 can be 4 cube. And also we can do 2 to the power of 4 or 2 to the power of 6. So I would use the smaller number for the base because that will be simplified most, right? So I will do log by 2, right? Log by 2. Now 64 is above. If I have like the dash like that, so 64 is above, so I write it on the top, and the base is 16, so right at the bottom. So now we rewrite it, log by 2 of 2 to the power of 4, log by this one is the power of 6, right? 64 power of 6. Power of 6, and then we have log by 2 of 2 to the power of 4. Now we use what? First we use the chain of base rule. Then we use rule number 6. We have the same base, right? And we have power. So that equals 6 over 4. And 6 over 4 we simplified at 3 over 2. Thank you for participating in this week practice questions. See you next time.